Welcome. In this particular demo we're going to have a look at a image ribbon to see how we have gone about implementing it so that it runs on a Android device. So just by way of running the demo for this, first of all, we have here a screen viewport into a world that contains a number of fish objects. So these fish are run at fixed intervals but at random y coordinates on the screen. So we are effectively scrolling through our level, looking at these different objects that are positioned within the world. The background, we have, this is where the ribbon comes in. So we have a single background image here that's seamless, and we're drawing it next to each other to give the appearance that sort of moving within a sandy and watery environment. So just by way of showing you the actual assets that we have for this here, we got our fish asset, so we're displaying that particular one, and we got our ribbon object, which is simply the water and the sand. It is seamless in that this side seamlessly joins onto the side that we have over there. So we're going to have a little look about how it is we have gone about doing that. And as per usual, we'll go through this, we'll sort of show some of the components that we have. And again, usual reminder, this is a demo, everything's all stuck together in one class for reasons of convenience. Really, it should be separated out. We have our game world, within which notably the objects and the ribbons will exist. We've got a render view, a view that we're drawing onto. And when we use the stuff, create the fragment, we'll create the world, create the view, we'll create our view that we're rendering to. And I'll come back to the world in a little second. We'll go down, we'll have a look at how it is we are drawing this out. So our render view here, we've got our screen rectangles. We actually are drawing to a region of the screen. When we create the render view, we're a little bit different here. So for the screen viewport, we are defining a viewport. I'm going to go back to the actual ribbon test that is 50 pixels around the screen, and depending upon the orientation, it will be a margin of at least 50 pixels from the side. So we're defining a viewport of that size. So it starts from 50-50. And depending upon, well, what is smaller, the width or the height, we'll size it based on the other one. So in this particular case, we're actually asking how big is the screen. It can be a little bit difficult finding these things. So all views can have a width and have a height, and this indeed is a type of view. But because sort of the view is inflated or constructed, it's not until the actual view objects are created and positioned on the screen that they know their own view width and height. So if I were to immediately ask view, okay, what's your width or your height, it would come back with a 0 initially until it has been added and has been arranged and set out. So what we're doing here is another way of getting things. We're going back to our activity. We're getting the window that this activity is on and the default display device for that. From that, we can get some metrics, some measurements of the display that we're actually running this window on. And what we're interested in here is the number of pixels high and pixels wide that it is. Because we're running this as a single fragment activity, and because we've requested we want to use all of the window, we want to remove any of the menu bars, then this is a safe way of us actually getting the available area that we have for displaying our game. So it works in this case. Depending upon other UI elements you have displayed, may not always work depending on it. Okay, so we size the screen viewport. We've got our usual on draw again. We're being cheeky, we're updating our world on draw. We shouldn't do that. Updating it, drawing it, going to sleep for a little bit, and that does that. So let's have a look at the actual world itself, because that's the thing which has all of the pertinent code for this particular demo. It is a world in which positive y points up, so you won't normally want that to be the case. So each of my fish, and indeed my layer viewport, I want to give it a bounding box. I want to give it its position and its size within my world. So I have my bounding box, same one we used in the viewport demo. It has an X and a Y, center location, has a width and a height, and two simple constructors for that. For my game world then, I'm creating 100 fish, giving each of them a bounding box, and they've got the bitmap for it. I've got my image bounds. This is for the background. So for my ribbon, I'm saying here's the image that I'm using for my background ribbon, and here is the bound for it. And you'll see how we use this when we're actually drawing it. We're going to create, give each ribbon a particular bound, and then just simply draw that onto the viewport, the layer viewport. And you'll see it's a very easy way of drawing our ribbon. We have another box for our layer viewport. This is the portion of the world that's currently visible. Setting up our world, how do we set it up? We define the layer viewport. So here we're assuming we have a layer that is, or a viewport rather, 1,000 world units by 1,000 world units. And it's currently positioned at position 500, 500. Again, these are just arbitrary values you would set up for whatever world you're creating. For our image ribbon, we are given this is the box for the background ribbon, and we're only really interested in specifying the width and the height of it. And we're going to make sure that the background ribbon, its bound, has the same height as our viewport, but we're making it slightly larger than the viewport, so it's a bit bigger than our viewport's width. And that was the assumption we made. If we make that assumption that our viewport is not bigger than the ribbon, then at most we only have to draw the ribbon twice to fill the full screen. Try to load in our fish and our background ribbon. We set up the fish to give them random positions along the y-axis and regular positions along the x-axis. When we're updating our world, we're simply scrolling it along, and all we are is scrolling the viewport. That's the only thing that we're doing here. Moving the viewport, that lets us see a different region of the world. Down here, as before, we've got our two rectangles we want to create. Again, rectangles of positive y pointing downwards. One for the source, this is the region of the bitmap we're copying out. One for the destination, the region of the screen that we're drawing to. And we've got our draw method. Now the draw method is actually quite straightforward and simple. It's going to call a couple of methods itself. We have one for drawing out the background ribbon. So whenever we come in here, we want to draw out our background. So this is the nice graphical area that we're drawing the fish on top of. So we'll have one method which will draw out our ribbon. We're giving it the canvas, we're giving it the region of the screen we're drawing to, because we need those. Then we're going to go through each of our fish, and we're going to have a method now, get source and screen rectangle. So into that we can pass a bound, we can pass the size of the source bitmap, we can pass the size of the layer viewport, the screen viewport, and then the two rectangles that will be populated. So they're being passed in, they're not being returned, we're not creating temporary objects here, we're reusing these objects and specifying whatever the relevant source and screen rectangles are. So this is basically our viewport method, the one that works out if you are visible, and if you are, whereabouts you're going to display. It's in an if statement because if it's true, it's visible. If it's false, it's not visible. If it is visible, I then calculate those two things and I draw out my fish from the source to the screen. No paint effect applied in this case. So this is the one for drawing the background ribbon. We'll come back to that in a second. This is basically the viewport method, and if you were to go back to the viewport demo where we're having a look at how we can create a viewport, this is in essence what we explored within that. So all we've done here is taken the source code that we had for our viewport and wrapped it up into a single method that we can call different times. Some cases we'll be calling it because we want to work out if the fish is visible. In other cases we're going to call it because we want to work out what region of our background ribbon are we displaying. So let's have a look at our ribbon code. So all of the ribbon stuff fits within this one method here. So it's not actually too complicated overall. What are we doing? We really have two components. We're going to have the first one, which works out which bit of the ribbon do we want to draw. And there's at least one draw request. And we have a second bit that then works out, do we need to draw a second ribbon to occupy the screen? So if I were, for example, just to comment this out, and we were then to rerun our demo, yes, let's see if the changes to that. What we would hopefully see here is the ribbon where we're drawing out the first half of it, but not necessarily always drawing out the second half of it. And unfortunately, we've had another crash from our tablet, so it hasn't done such a great job about being able to stay upright of late, which is a little bit of a problem. But we'll let the tablet start up again, and then we'll draw it out. Okay. So as that's firing up, actually we'll talk about what we are having within this one here. Now, the first bit is we want to work out, so we know we're going to have to draw at least one ribbon image, and we might cover the whole viewport, or we may not. But for drawing the first one, we have to work out, well, where do we draw it at? It's going to have a fixed width, it's going to have a fixed height. The only thing we're calculating here is its X location. Its Y location will always be in the middle of the screen. And this is not as top left. For the bounding box, we're assuming that we have objects sized in the middle. So the image ribbon offset here, similar to the thing we looked at in the lecture, we work out, okay, well, where does the layer viewport begin? We're dividing this by the actual width of the ribbon, and we're using integer maths, and this will tell us how many ribbons across do we have to go until we get our first ribbon that falls within the viewport. And from that, we are calculating the central X location of that particular ribbon. So this is the number of ribbons times the width of it plus half of the width. It takes us into the center of it. And we're then, we've got a bounding box then for this, and we're calling our get source and screen rectangle. This is the one that says, okay, for this particular bound, we know that it will fall within the viewport. What is the source rec for our ribbon, and what is the screen rec that we are drawing to? So if we fire this up now, we can see the effect of, hopefully be able to see the effect of drawing out that single individual ribbon. So we start now, we're drawing the whole bitmap. This is where we should be drawing the second copy of the ribbon, but we don't have it. And then we're jumping back to drawing all of it, but we're now not doing the second bit. So you can see we do need to have a second one drawn in here where we want to have the seamless. The first one, occasionally it'll disappear off, then it'll restart again. So this is only seeing the first, if you like, copy of the image as we scroll through. And let me just dismiss this one. If we go back to this one here, and we will re-include this piece of code. What we have is, for our if, is a check to see, well, do we need to draw a second one? And the condition here is if the background ribbon, if it's right-hand side, so this is the right-hand side of the ribbon, if it is less than the right-hand side of the viewport, so in other words, the ribbon finishes before the viewport finishes, that is our condition to say that there is a section then of the viewport that we haven't filled in. So what we will do is more or less exactly the same as above. We're updating the X location to move it one width to the right. So this is drawing effectively the next copy of it. We're getting the source rectangle for that and the screen rectangle, and we're then drawing it out. And assuming the emulator holds up, we will be able to see the effect then of that being drawn. Viewport test, not viewport, ribbon test. So now we have, probably at this point, you have the second image coming in, but because it's seamless, you can't get to see that there is actually two draw requests occurring at that point. So it's straightforward, it's reasonably simple. This little bit of fragment here, combining it with some of the viewport stuff that we did earlier, that's all that we actually need to have a ribbon. If we wanted to get fancy and we wanted to use a parallax effect where we could have several different ribbons, then the only difference we would have to this one here is when we are updating the particular location there, we would be interested in working out how much has the ribbon changed, has the viewport changed, and then depending upon the type of ribbon that we have, we would scale that accordingly. So if the viewport was to move by 10 units, maybe our topmost ribbon, the one that's closest to the viewport, we would move it by 10, the one that's behind that would move it by 5, the one that's behind that, if we did a 1, we may only move it by 1. But you can layer these things together to give the appearance then of depth through a parallax effect. Reasonably easy extension to what we have here.